Did you know that the Earth, our home, is over 4.5 billion years old, which is about 1/3 of the age of the entire universe? A sense of wonder and awe fills the air as we ponder this staggering fact. To put it in perspective, if the universe's lifespan were condensed into a single year, Earth would have appeared on the scene around the beginning of May. Our planet's age is a testament to its resilience and the enduring nature of the cosmos. But how did it all begin? What colossal forces birthed the universe, our galaxy, the Milky Way, and our own solar system? There are several theories that scientists have proposed over the years. The most widely accepted theory about the universe's birth is the Big Bang Theory, suggesting that the universe originated from a singularity, an infinitely dense and hot point around 13.8 billion years ago. An explosion of epic proportions caused the universe to expand and cool, leading to the formation of galaxies, stars, and eventually planets. The Milky Way, our galaxy, is believed to have come into existence about 13.6 billion years ago. It's an elegant spiral galaxy that houses billions of stars, including our Sun. But the formation of our solar system is a tale of cosmic dust and gas, gravity, and time. Around 4.6 billion years ago, a cloud of gas and dust in space collapsed under its own gravity. As this cloud collapsed, it spun and flattened into a disk, with most of the material spiraling towards the center to form the Sun. The rest of the material clumped together to form planets, asteroids, and comets, giving birth to our solar system. Our Earth, a tiny speck in the vast cosmic sea, has a rich and complex history, one that we are only just beginning to understand. It's a testament to the majesty of the universe and the enduring power of creation. Now that we know how old Earth is, it's time to dive into its chaotic and fascinating birth story. Earth's story begins with a cosmic cataclysm, a stellar explosion known as a supernova. Picture the colossal scale of this event, a star, hundreds of times more massive than our Sun, reaching the end of its life cycle and in its death throes, unleashing a blinding burst of energy that outshines entire galaxies. This explosive event is not merely the end of a star, but also a beginning. The material expelled by the supernova, rich in heavy elements, becomes the building blocks of new stars, planets, and indeed life itself. Among the debris of this celestial demolition, a specific cloud of dust and gases, the solar nebula, started to take form. The solar nebula, a swirling, chaotic maelstrom of matter, was no ordinary cloud. It was a cosmic nursery. Under the relentless pull of gravity, the nebula began to collapse onto itself, growing hotter and denser at its core. This process, known as accretion, was the first step in planet formation. As the nebula continued to collapse, it began to spin faster and faster, creating a flattened disk of material. Within this disk, solid particles started to collide and stick together, forming larger and larger clumps. Over time, these clumps grew into planetesimals, the seeds of future planets. Amidst this celestial chaos, one particular planetesimal was destined for greatness. It continued to grow, its gravitational pull attracting more and more material from the surrounding nebula. This growing planetesimal was the nascent Earth, a cosmic infant in the grand scheme of the universe. Yet, this was only the beginning of Earth's remarkable journey. The planetesimal had to survive countless collisions, each one adding more material and shaping its form. Through this violent, chaotic process, the Earth was born. From a violent, chaotic beginning, Earth began to take shape, but it was far from the planet we know today. As we delve deeper into Earth's epic story, we'll uncover the unique processes that sculpted our planet and gave birth to life. So, buckle up and prepare for a journey billions of years in the making. Fast forward a few million years, and the Earth began to cool down, forming a thin crust on its surface. This crust, a mantle of rock that enveloped the molten interior, was Earth's first skin. It was a protective layer, guarding against the harsh realities of space and providing a solid foundation for the future. But the Earth was not content to stay still. It was a dynamic, ever-changing body, and beneath its crust, powerful forces were at work. The heat from Earth's molten core set the mantle in motion, driving the movement of tectonic plates. These colossal chunks of crust, adrift on the sea of semi-molten rock, collided and separated, creating a dramatic dance that would shape the face of our planet. As the plates moved, some were forced upwards, forming the great mountain ranges we see today. The lofty Himalayas, the rugged Andes, the majestic Rockies. Others plunged into the mantle, a process known as subduction, creating deep ocean trenches and sparking volcanic activity. Meanwhile, on the surface, another sculptor was at work. Weather, the artist of the air, began to carve the Earth's face. Wind, rain, and ice wore away the land, a process known as erosion, creating valleys, canyons, and the intricate patterns we see in desert sand dunes and limestone pavements. Simultaneously, the relentless action of waves shaped our coastlines, creating cliffs, beaches, and intricate sea caves. Rivers too played their part, cutting deep gorges into the landscape and depositing sediment that would become fertile plains and deltas. And so, over millions of years, the Earth was shaped and reshaped, its face constantly changing as the forces of nature worked their magic. Continents formed and broke apart, oceans appeared and disappeared, mountains rose and were worn away. Through it all, the Earth's crust remained, a testament to the incredible geological processes that had taken place. The Earth was evolving, transforming into a world capable of supporting life. And as we'll see in the next scene, life would soon make its first tentative steps onto this newly sculpted stage. With the stage set, life made its grand entry on Earth. In the early chapters of Earth's grand narrative, our planet was a fiery, inhospitable landscape. But over time, it cooled down and oceans began to form. In these vast primordial waters, life emerged in its simplest form. These were humble beginnings, with organisms no more complex than bacteria, but they were the pioneers of life on Earth. These early life forms were single-celled organisms, much like today's bacteria. They thrived in the Earth's oceans, absorbing sunlight or chemical energy to survive. Over time, these simple organisms began to evolve, diversifying into a myriad of forms. Some developed the ability to harness sunlight more efficiently through a process we now call photosynthesis. Photosynthesis had a profound impact on our planet. It produced oxygen as a byproduct, gradually transforming the Earth's atmosphere. This oxygenation event set the stage for the emergence of more complex life forms. The oceans teemed with life, from tiny plankton to massive, multi-celled organisms. Over billions of years, life continued to evolve, branching out into a dazzling array of species. From the depths of the oceans, some creatures ventured onto land, adapting to new environments and giving rise to a whole new world of life forms. The land was soon populated by plants, insects, and eventually animals. Life's journey on Earth has been anything but smooth. It has faced numerous challenges, from volcanic eruptions to ice ages and mass extinctions. But each time, life has shown an incredible resilience, adapting and evolving to survive. Today, we see a tremendous diversity of life forms on Earth, from the smallest microorganisms to the largest mammals. Each species is a testament to life's remarkable journey, a journey that has unfolded over 4.5 billion years. Life had taken root on Earth, but the planet's journey was far from over. As we look to the future, Earth's geological history can provide us with fascinating insights. Let's delve into the fascinating world of geology and see what it might tell us about our planet's future. Our Earth's crust, that solid outer layer we live on, is broken into giant puzzle pieces called tectonic plates. These plates, over the course of millions of years, shift, collide, and drift apart, causing earthquakes, forming mountains, and creating new lands. Looking forward, we can expect this dance of the tectonic plates to continue as they have done for billions of years. The face of our planet will keep changing, with new landforms emerging and old ones disappearing. Sea levels too have fluctuated throughout Earth's history, driven by the waxing and waning of ice ages. As global temperatures rise, we are likely to see an accelerated rise in sea levels. This could reshape our coastlines, submerge islands, and cause significant changes in our ecosystems. Climate change is another significant factor. The Earth's climate has swung between periods of warmth and cold over millions of years. But now, the rapid pace of human-induced climate change is something the planet hasn't faced before. Our activities, from burning fossil fuels to deforestation, are pushing the Earth into uncharted territory. We're not just observers in these processes. Human actions are now a significant geological force, shaping our planet's future. We've stepped into a new geological epoch, the Anthropocene, where we are the drivers of change. This realization brings with it a great responsibility. Our actions today will determine the Earth's geological path and the legacy we leave behind for future generations. As we learn more about Earth's past, we can better prepare for its future. After all, this is our home, a geological marvel that's been billions of years in the making.